Hi, I'm Greg Favalora from Optics for Hire, the optical product engineering company near Boston, Mass. This video explains a technology that lets you turn any fast display into a three-dimensional display without glasses, from handheld to desktop and beyond. We built a prototype at Actuality Systems, and it was the first 3D display whose imagery caused me to involuntarily reach out and try to touch the 3D scene. In our case, we made it from a repurposed DLP-based Dell projector and two lenticular sheets, but it used lenticulars in an unusual way. It produced imagery with 198 views at XGA resolution, that's 1024 by 768 for each view. The system was driven by a desktop Windows XP PC. This patent application was filed by Actuality Systems and is now owned by Optics for Hire. It describes many ways to make floating, three-dimensional hologram-like imagery. The architecture can be applied as small as a handheld device, such as an iPod, up to desktop displays and larger. These are real moving images you can see from side to side, and they can be seen without glasses. It solves a long-standing problem in 3D display. How do you make an auto-stereoscopic display with enough views for sufficient depth realism, like 200, while having high-resolution views? Whereas typical lenticular displays cut the resolution by the number of views, this invention uses lenticulars to perform beam steering without reducing the resolution. One concept taught in this application is using lens arrays to continuously sweep high-resolution imagery from a rapid image source across the viewing zone. For example, consider two lenses configured as shown. Their diameter and focal lengths would be on the order of millimeters. For the sake of discussion, place them so their foci coincide. A bundle of telecentric rays enters the rear of the first lens, comes to a focus in the middle, and then emerges as a bundle of telecentric rays. What if we were to displace one lens relative to the other? As you can see, it becomes a beam steering device. Then, tile more and more of these lenslets together in a sheet. Here you can see that you've created a large-scale, continuous scan beam steering sandwich. You can create a three-dimensional display in a variety of ways. One way is to illuminate the lenticular arrays with a fast projector, such as MEMS-based DLP technology from TI. You could take an XGA resolution projector running at 15 kHz. It would be driven by a computer that's computed 200 perspective views of a 3D scene. This could all be packaged into a desktop or television format, and it really does depict 3D imagery. The algorithms are either well known or described in various Actuality Systems, Optics for Hire patents, and patent applications. What if you wanted a handheld auto stereo display? One concept is to use a fast OLED backplane immediately behind the lens array system. As I mentioned, we prototyped this at Actuality and it worked very well. It is now owned by Optics for Hire. If you have any questions, please contact us at John, John, @opticsforhire.com.